Well, Carlos, I'm excited to be here, and this is a continuation of part one, where what we're doing is we're working our way from the top of the tooth down. So we were talking to you about how do we find the canal orifices, how do we not perforate, but if we do perforate, what do we do? And then we got into, we try to figure out how long the canal is, and then start working and shaping their canals. So the big thing about file development is, man, over the last couple decades, they've changed. It seems like every 6 months, somebody has a new file design, like you said, asymmetrical, symmetrical, all the different cutting designs and how to use them. And it gets really frustrating. But I've been impressed by you, using some of the files that you've told me to use in the past for the last 5 years. They've all worked great. But now you've got a new file that you've worked on, and it's been heat treated in a way that I think is very innovative. So a couple questions I wanted to ask was, one, can you describe again the file? And then two, how they're heat treated? And one of the questions I have is, it just seems so common sense to have designed the files the way you have. Why other manufacturers haven't done that? So why don't we start off right there?
Those are very good questions, very, very good questions. So first of all, the thing about the heat treatment is the development of the NiTi files. So you know that we start with stainless steel hand files, carbon steel before that, and then we came to the NiTi, and it was a revolution from Walia, from these people that start to use these ortho wires in endo files. But the hand file was not that thing that we were expecting, because NiTi is a totally different animal than stainless steel. And that is very important to our conversation today, because one of the things that I notice as an educator, and you notice as well, is when you teach about NiTi rotary or reciprocating files, and especially now with the heat-treated files, people has a tendency of repeating the same movement with their hands, not the movement of the motor, but the movement of the hands in the same way. And that is one of the biggest mistakes. So now that we are implementing and launching these heat-treated files, we noticed that people call me and said, hey, I'm using the Genius ProFlex that is heat-treated. This is the Genius version of the heat-treated version of the original Genius. And apparently I'm not getting the same sensation. I'm not getting the space that I want. Apparently it's not cutting. And this is just apparently. This is just a sensation, because heat-treated files doesn't transmit the same sensation for your hands of the non-heat treated, as stainless steel doesn't do the same perception of NiTi, or vice versa. So this is one of the points that I need to highlight. Heat treated files are a different animal than the not heat treated NiTi files. That being said, we have to be very careful. And if we were less pressure, apical pressure forces on application on changing from stainless steel to NiTi, now we have less apical pressure changing from NiTi to NiTi heat treated. So this is very, very important. And this is one of the things that I don't see anybody talking about. So that being said, of course, I will show some of the files of why we heat treated, but it's very important to understand that the pressure needs to be very, very light, way lighter than with the original NiTi, not heat treated, and of course, way, way more lighter than with stainless steel. So if you want to know what's the pressure that you have to do, take a contra angle, put a file, take a scaler, these little scalers that you use in your kitchen, and just touch the plateau, the base of the scaler, with the tip of the file. 100 grams is 1 Newton. So to break a file, you have to have between 2 to 3 newtons to break a file by torsional fatigue. A very little file like a 1303, 1704 for 1705 needs less than that, 1.5. So 150 grams is 1.5 newtons. More than that, you are doing too much pressure. This is the way that we can calibrate our forces when we are using, when we are doing our instrumentation. Let's see some slides here. Anyway, so a heat-treated file has some features that are very, very interesting. And the reason that we came with heat-treated files is exactly to increase cyclic fatigue resistance. So cyclic fatigue is when the file is in a curvature, for example, and is going inside, outside forces, trying to do tension and compression, tension and compression, tension and compression, and all of a sudden this file breaks. It's important to know that it's not only cyclic fatigue, but the sum of the two, torsional fatigue, when the tip of the file stops and the file is still rotating or reciprocating, and then you break the file, plus cyclic fatigue. Cyclic fatigue itself, it's very unusual that you are going to break a file just with cyclic fatigue, but the two together works concomitantly, works at the same time, so you have this perfect scenario to break a file, especially in a curvature in molars, right, in curved canals. And why always this file will break at the curvature level? Because in that area you have some sort of a constriction of the canal there. Take a straw and try to bend the straw. When you bend the straw, at the angle that you bend, you can see that you have a flat area there. That flat area gives you two diameters, one big diameter and one very small diameter. That is exactly what happens on a curved canal at the curvature level. So even though you have a big diameter, but you have a small diameter there, and that is where you have this constriction that will take the body of the file and start to create this torsional stress on the file. Plus, it is at the very middle of the curvature that you have the point of the cyclic fatigue. So the two will be pointed exactly in the middle of the curvature. So that's why you have the problem. So basically, when you do a heat treatment, you are looking for increased cyclic fatigue resistance. And we did, actually. For example, if you take the Genius ProFlex and with the heat treatment that we gave for different heat treatments, tailored heat treatments for different files in the set, what you can see is 3 times more than the Vortex Blue, for example, or 5 times more than the original Genius that was not heat treated. So instead of breaking in 300 seconds, you have probably 1,300 seconds, 1,200 seconds, so something like that. It is amazing how you increase the cyclic fatigue resistance by doing the heat treatment, but not torsional. For torsional fatigue, what happens is you have some kind of distortion that you can see more than in a non-heat treated. So that is another tip, and this is very important. It's not only that you have to be very light on the force that you do, but more than that, you have to do your instrumentation, and after 10 seconds, remove the file, inspect the file. If there's any distortion on this file, throw away and reevaluate what you're doing, because you're doing too much pressure, and the file has this plastic deformation. So before plastic deformation, you have elastic deformation. Elastic deformation is when the file do some kind of deformation. When you remove the file, it goes back to original shape. This is elastic deformation. Plastic deformation, the file do some deformation and then goes to the plastic deformation that is a permanent deformation. And after the permanent deformation, what you have is breakage. So you want to catch before breakage. So that's why we have to inspect, always inspect the files, especially in curved canals, especially in very constricted canals. You know what is important when you are doing a calcified canal? What is important is not to stress the file, especially at the very end, the last 3 millimeters. So if you put a file and you feel that the file is not going, don't try to force, don't try to get space, especially in rotation. What you have to do is to decrease 1 point. So if you're using a 2504, go to the 1705. And even if the 1705 don't go smoothly, goes to the 1303. If the 1303 is not going, take a hand file number 10 and goes 1, 2, 3, 4, 5 times. Replace the number 10 again with a new number 10 and go again, handling manually. That is the way that you get a safe path to the apical part or to the working lens. Okay, and what is the heat treatment? Basically, in a shell, what is heat treatment is moving phases, right? So the austenitic phase, that is the name from the metallurgical engineer Austin from England. He discovered this austenitic phase on the metal. It's pretty much one design of the atoms, and then the bonding between these atoms, the metallic bonding, is very short. So when you do some kind of a load forces or even temperature, what you do is you increase the deformation, but because the metallic junctions are very, very short, so they will deform, but they will come back. That's why we call spring effect. You take a non-heat treated NiTi file and you do a load pressure with your finger or whatever, and then when you unload, the file goes back to the original straight position. In the martensitic, that is Martin from a German metallurgic engineer. So this guy discovered that you can do some kind of a treatment that is a heat treatment actually on the NiTi alloy, and then you change these atoms and these forces that join the atoms together, and you have a little bit more distance between the atoms. And then when you do some kind of load, then you deform, and this deformation will be permanent, right? Interestingly, because if I heat this file here, we'll go back to austenitic. So this is the two more important phases. One, spring back effect. Another one, you can pre-bend the file. But there's something in between that is called the R phase, that is a transitional phase. But basically, what happens is, if you take the files that is in the market and they are heat treated, all of them has the same heat treatment, right? So it's blue or gold or control memory, doesn't matter, but they are all the same. And I never understood, honestly, why to do the same heat treatment for a 1504 and for a 4004. We know that a 1504 is way more flexible by design, by metal mass, than a 4004. That's why you can bend a 1504 with your finger very easily. And when you take a 4004, you have to do more pressure because there's more metal there. Does that make sense? Mm-hmm. So yeah. Basically, a 1504 is by design more flexible than a 40. And exaggerating a little bit, the number 10 file is more flexible than a number 60. So I never understood why we use the same heat treatment for both, for all files in the sequence, because if you take, for example, some heat treated files, a number 1504, for example, you put inside the canal, when you don't do any force when you remove, it's totally spaghetti, right? It's kind of a smooth wire. The deformation is so fast, these files are so martensitic that you cannot even cut them with these files. So that's why we came with this idea of doing a tailored heat treatment. So with this tailored heat treatment, the same flexibility that you have with in a 2504 or a 1705, you have with the 6004. So if you see here in the slide, you can see that, let me do this. You can see that this 2504 here is purple, and this 6004 is gold. Why? And this is blue. Why? Because we tailor different heat treatments for different files in the set. At the end, if I do the same load, the same forces for deformation for the 3 files, I have exactly the same deformation on the 3 files. Even though the 2504 is way more flexible by design, by metal mass, than the 6004. So for small files, sometimes I want a little bit better response in terms of cutting, because this is a phase of your instrumentation that you need to assure that that file is open a little bit. With the 60, by design, those files will cut a lot, right? Because they have more metal mass, flutes are deeper, the edges are more prominent, so they will cut more. A number 80 hand file cuts more than a number 10. So that's why I need to compensate everything here in terms of the heat treatment to make sure that this file here will cut very good, will cut enough to open space for the others. And those files here are super flexible to not restrain the canal or create a ledge or anything like that. So the heat treatment is not only one thing that you can just do the same heat treatment. And unfortunately, I have to tell you, the only file that has different heat treatments are the Genius ProFlex. The others are or blue or gold from 15 to 80, blue or gold or black contour memory. There's a new one that is violet as well, but always the same heat treatment. And this is, in my opinion, a big mistake. So if you see exactly what I'm saying, if you see in the market, you have the non-heat treated that is very austenitic, those with the spring back effect, and you have very martensitic, like the Max wire, contour memory wire, that they are almost black. Those files, if you take a 1504 and you put it inside the canal, will come back as a smooth wire because it's so martensitic that the deformation, the plastic deformation goes very quickly. And of course, you have the M wire, the blue wire, the C wire, gold wire. You have all these heat treatments in the market, but we did different heat treatments for different sets of files. The small files, the small diameter files, we started with the violet or purple heat treatment, the blue for the intermediate, and the gold for the big dudes. And of course, here, I have a little bit more austenitic. That's why this A here, and you can see in the box of the file. And here, more martensitic, more austenitic, because I want to create a situation that I can cut enough, but it still have flexibility. So in our box, we show the alloy phase expression that is exactly more austenitic, more martensitic, or half-half. And of course, we show other things that is very important, like the cross-section, the speed, the torque, the angles in reciprocation, and so on. This is the heat treatment, Mike, and I think that I answer all your questions regarding the heat treatment, but it's important to say again that heat-treated files needs to have less pressure. This is very important because you don't feel the same resistance of the walls with the heat-treated files, you don't feel in your hands like you feel in not heat-treated NiTi, and more than that, with stainless steel. So you can feel with a hand file, stainless steel hand file, when you touch, when you put inside the canal, you start to feel everything because they are more brittle, right? NiTi not heat-treated is less brittle, and NiTi heat-treated is way, way less brittle than stainless steel. So you have to compensate your sensation and do not press. You know what is the best movement to do? Put your file inside the canal. When you feel resistance, just feel resistance, withdraw 1 millimeter and start to do brushing movements. Brushing, 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 brushing. Naturally, the file will go more and more apically. Why? Because this, when you put the file inside the canal, the taper file, when you put the taper file inside the canal, is not the tip of the file that you are feeling resistance, but the body of the file. So when you put the file, the body of the file is giving you, hey, there are some resistance here. So if we withdraw the file a little bit and free this file and work laterally, you are removing exactly the interference of the body, not the tip. So then the file naturally will going down, 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 and down. And of course, 10 seconds of instrumentation, 30 seconds of irrigation. This is mandatory as well.
Very cool. No, it's amazing what you're able to do. So it begs the question, it makes sense. So why don't other manufacturers do it? Is it a patent thing, or is it just difficult to do this? I know you did a lot of research to figure out how to do the heat treatment, but if it makes so much sense, why don't we have a dozen manufacturers with the same?
I really don't know this answer.
No one's smart enough.
I really don't know this answer. What I know is, if you talk with the key opinion leaders in endo, the international and domestic key opinion leaders, all of them will say exactly the same thing. Why a small diameter file needs the same heat treatment that the big dudes, right?
Mm-hmm.
Why?
Mm-hmm.
That's no reason for that. There's a lack of interaction between manufacturers and research, and you know that. So that's why I think that in my position as a researcher, educator, endodontist, and being part of R&D like yourself, so this is the perfect connection between the reality on our offices and the manufacturer plant or the R&D sector of a manufacturer, right? Mm-hmm. That being said, I don't know why nobody did that. We have a patent on that. It's one of my patents, actually. There's another patent that it's very important to say there's another patent about this, but they do the heat treatment before cutting the file. That is kind of makes no sense for me, because you have to cut the file first. You have to design your file to make sure that it's a 2504 or it's a 6004, and then you do the heat treatment. That's why our files has 3 colors. If you see, there are some heat treatments that is done before cutting, that is a different process with a different patent. I don't know if it's to go around of our patent, maybe, but our patent is very clear. We do the heat treatment after cutting the files. That's why our files, they are all the blade and the intermediate part, all the metal part is with one color, or purple for more austenitic, blue half and half, and gold for more martensity.
Well, that's good. I hope you get to control the this design for a long, long time. So the next question would be, in these two sessions, you've covered quite a bit. We've gone from locating the orifices, talking about the little trumpet attachment that you've developed. And again, that makes so much sense. The files, you talked about the negative pressure irrigation during the last session. So there's been a lot of information. I think it's great to have information, but a lot of times the shortcoming of all education is, okay, how do I implement what I now know? So I see things differently because of the knowledge that you've shared with us. How do we integrate this so we can all enjoy success, and how do we figure out how to get going?
So that's a milestone for us, right? For education like me and you and the others, we always want to have results Monday, right? Mm-hmm. And basically what we see in the big majority of the people who comes attending our lectures, and I saw your lectures as well, and I know that is your reality as well. They want to simplify things. So every day I receive phone calls here from doctors calling, Carlos, I want a streamlined technique. I want something that is easy, because I do everything. I do crowns, I do preps, I do dentures, I do implants and perio, and I cannot just stop and create a environment like endodontist in my office to perform endodontics, right? And the reality is this: we have around 5,000 endodontists in this country. In my country, my original country, now that I am a citizen, but in Brazil, we have 5,000 endodontists, most probably in my state, just in Paraná state, right? So it's different. So in Brazil, it is way easier to refer all endo. But here in the United States, what we see is this reality of GPs doing 80% of the endo treatments done here in the United States. And it's interesting that 80% of the GPs do some kind of endo as well. So it's 80% of the whole endo treatment being done in the United States is being done by GPs. On the other hand, if you take all the GPs, 80% of them do some sort of endodontics. So it's a great responsibility for us when we teach these people, when we teach them how to do it. The first thing that we have to say always, do use the rubber dam isolation. If you are not able to use a rubber dam, refer, because without rubber dam, there's no endodontics. And this is very, very important always. In all IFUs that I wrote in my life, I always put rubber dam is mandatory for endodontics. And not only endodontics, but to prepare a post as well. So put a rubber dam, prepare your post, install your post, remove the rubber dam, right? Another thing that's important to say is this: a streamlined technique, it covers maybe 80% or even 85% or even 90% of the cases. There are some retreatments and very curved canals, MB2s in upper molars. This kind of a situation most probably will be covered by endodontists, and they can do that. There is their forte, right? So let's try to see a very streamlined technique here. I will put in my slide again here. So this is a technique using the Genius Pro Flex. And with the Genius Pro Flex, we have all files in the set, right? So the Genius Pro Flex is a complete setting of files from A to Z. And I need to explain why I came with the full collection, because I hate to mix and match. I hate to mix and match. That's why exactly we have 3 types of heat treatments. Because what I see, all the endodontists that I talk with, they say, no, I don't use just one collection of files. I use one for glide path, I use another system for pre-flaring, and I use another system for open space, and another one with big dudes because I want a very control memory file on the big files. So I said, why we don't put everything together? We can, right? Of course, there is very personal preferences. Yes, I understand that. But in the Genius sequence, you have not only different heat treatments, but you have different cross sections as well. Because there are some cross sections like the triangular rhomboidal cross section for glide path and for final enlargement. Those are perfect. But if you take an artifice shaper that you want to work hard on that part, the two first and second thirds of the canal, that is the cervical and middle thirds, you want to open the space very quickly, and then you need a S cross section because it is a little bit more cutting, is a little bit more aggressive as the 2504. So we put everything together, different heat treatments with different cross sections, including different angles as well. So the recoidal angle is very important. But let's go back to your question. This is what we can do with the standard cases selection that I will show. That is what we call the intro kit, right? So curved canals, like mesiobuccal, mesiolingual of lower molars, curved canals of upper premolars, buccal and lingual, and of course the buccal canals of the upper molar as well. See, these are curved canals. It's not 90 degrees curve, is not very constricted or very calcified canals, but pretty much if you see, we can do molars and we can do, of course, premolars with these standard cases. For distal canals, palatal canals, or even single canals, we have the large files to complement what I'm showing you right now. So just keep in mind that if you want to enlarge a little bit more, after 35, you have the 40, the 50, and the 60, and those are control memory, very flexible files as well. So this is the kit that I like to use for these situations. So I have here what we call Curvature Sweetener, that is a 2506, but it's not a normal 2506. This 2506 has 19 millimeters, 14 millimeters of blade, and the wire is 1 millimeter. And I remember one of your questions back in one of our webinars about minimally invasive approach. This is minimally invasive approach. It makes a lot of sense because when you jump from a 25 to a 35, this guy here plays a very important role in all things, because as you can see here, I will go to a certain point of the canal. I'm not going to the working length. I go to the working length with the 2504, and then I jump from 25 to 35. And why I'm not using the 30? Well, because all this space here until here is open, the 3504 just work at the very end, 3 or 4 millimeters. So that's why I can jump from one to other. Another question is why I don't use a 2506. Because at 2506, we enlarge too much the cervical part that we don't want, because the resistance of the root after your restoration. But enlarge more than 25 in the very apical part, that is the most important part that you want to clean. So in this intro pack, back to your question about heat treatment, we have a gold, very martensitic file here, very flexible, a more austenitic file here, because it's a 2504, this is a 2506. And here the 3504 is blue, and it is flexible enough, but not super flexible as a control memory. So this is the sequence, it's very streamlined. First of all, you are going to scout the canal with a number 10. This is pretty much standard for every technique, right? So this is one canal, second canal, third canal, and eventually a fourth canal. So basically what you're doing here is just scouting and see, wow, this is a canal. That's why we put this file at the level of the curvature, not too much in depth, because I don't have my working length yet, right? Second file to use in rotation is the Curvature Sweetener, that is the 2506, a short one. And differently than an artifice shaper, that is a big dude. This curvature sweetener, even though it's a 2506, but because the control memory martensitic heat treatment that we gave for this specifically file, that's why it's gold, you can go a little bit after the curvature. So why I want to put 1 or 2 millimeters inside the curvature? Because I want to work in that flat area that I told you that is a very dangerous part of the path to the apical part. So I want to exercise a little bit that those two diameters. Of course, I have one big that I don't need to care about, but the little one, I want to amplify a little bit to be able to put my 2504 without any damage for the 2504. And that's why I put the nickname Curvature Sweetener, because I want to make this curvature sweet enough to be able to put the 2504.
Yeah, no, I like the name Sweetener.
Yeah, right? Better than sugar.
That's right.
So after that, I will do my working length determination, of course, using a hand file. With my apex locator, I can use my apex locator. I can use my motor with built-in apex locator. And with that, I can use my 2504 to the working length, up to the working length. Interesting, you can see here reciprocation or rotation. Why I put that? Because in our motor, the ACE, you have the Genius Auto Sense. And Genius Auto Sense is always starting rotation, but if you press too much, goes to reciprocation. When you release the file, goes back to rotation. So I train myself, and I really want everybody to train, put the file in rotation and try to be very kind with this file, not going to reciprocation, never. This is the sweet spot, right? If you pressure too much, instead of deforming the file or even breaking the file, the ACE motor goes with the Genius Auto Sense, goes to reciprocation in a safe mode. Hey, be careful. Then you withdraw a little bit and goes back to rotation. You see? So it's kind of an educational mode in a safe and educational mode. I always have fun with these things. I don't know why. I think that I have some problems in my brain. After that, we are finishing with the 3504. Not the 2506, but 3504. So a lot of people just go back to the 2506. We don't have a 2506, a big dude, or a 21, 25, 31. We just have 19, just because I don't want people to finish with the 2506. Does that make sense? Mm-hmm. I want to finish with the 35. So about cross sections, just you to understand why cross sections are important and why we don't need to mix and match. I want to cut denting. That's why Curvature Sweetener is as cross section. I want to cut denting at the very apical part. This is my first approach. Every time that you have a first approach, you want to cut more. So first approach as cross section. Second approach to the working length. Now I have a triangular rhomboidal cross-section. The old Genius were as cross-section, and we learned the lesson. People complaining about, well, sometimes I feel that is sucking the canal is sucking my file. I need to be careful. Now you don't have this situation because with the triangular cross-section, you have a smooth path, a smooth sensation of cutting. Cuts less, but I don't want to cut too much because I already cut enough with my 2504. I just want to give a convenient format for my irrigation and of course for my obturation. Simple like that. This is super easy to do. So let's do it. So I'm scouting the canal here. You see, just scouting with a number 10 back and forth, just one canal, two canals, 3 canals, that's it, right? Right after that, now I'm going with my first file, that is the Curvature Sweetener. Look, it is the curvature a little bit more. So I can go to my X-ray, I can do my measurement, and after the measurement of the canal, I will take 3-4 millimeters. Usually in the X-ray, you have a pretty much accurate temporary working length by doing the measurement of the length into the curvature a little bit more. So let's say that is my whole temporary working length is 20. So the curvature will be around 16, 17 maybe. So this is the working length, temporary working length that we are going to put on the curvature sweetener, right? So I go to my ACE, I put Genius Auto Sense, and I start in rotation. If I do too much pressure, we'll go to reciprocation, say, hey, 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 too much pressure. Then I throw out the file, go back to rotation, okay? So I'm going to the Genius Auto Sense here, as you can see. Super easy, you just press the system button. And every time that you turn on, turn off, and turn on again, you'll be coming to the last system that you pick up. And I can do just in rotation. If you don't want to use the Genius Auto Sense, you can do just in rotation. But then all the files, you need to change the file by the rotation and torque that you want to use. So with the curvature sweetener, I'm going basically to the middle of the curvature. Now it's time to do my working length determination. And my working length determination pretty much is being done with the ACE as well, or any apex locator. Put the file in the position, hook the file, hook, determine the working length, the 0 point, right? Open a little bit this space. Look, this file here is going to the working length right now. And this file will be the patency file. So every time that I change files, I go with my patency file to open that little space between my working length and the Freeman axis. Once I did that, now it's time to the 2504. 2504 going to the working length, as you can see here, and it's pretty much back and forth movements, back and forth movements. After that, 10 seconds, irrigation. So let's say that my file didn't get to the working length, but I am working 10 seconds. This is the time to go to your Sonus or your piezo and do your irrigation, okay? And irrigation, we already talked. We use concomitant irrigation with activation. That is very important in this sense. And always coming back with my patent file. Patency is very important, not only between instruments, anytime that you want to do it, right? Because patency allows a better approach of the liquid, of the irrigant inside the canal to the dentin walls. And I will finalize with the 3504. So my 3504 will gently go in. Again, I can use the Genius Auto Sense. If I do too much pressure, we'll go to reciprocation and go back to rotation. But it's pretty much a very streamlined technique. And always after 10 seconds, I'm going to use my irrigation. I can use any piezo or even cordless piezo, but it's important to use with irrigation at the very same time that you are doing the activation. If your device doesn't have a reservoir, doesn't matter, is not a problem. Syringe and cannula, put the irrigation at the pulp chamber and go with your chip doing the activation. It can be a polymer chip, can be a metal chip, can be a nitide chip, doesn't matter. But it's important to do not only as a final irrigation, but during all the process as well, right? If your chip is not, it is too big for going to the working length, that's where you have to use the syringe and cannula, right? But if your chip is small enough to go to the working length, go with your chip to the working length. It's very safe. The Genius Auto Sense, just you explaining again, is rotation, but if you press too much, go to reciprocation. So as you can see, I'm going to the very end here, and in rotary movement, and all of a sudden I can, if I press too much, I go to reciprocation. So it's a very smart, let's put it in this way, system. As I told you, Mike, you have to always use your irrigation. right? So starting with the Curvature Sweetener, 2504, in between, a lot of irrigation and activation. Again, if you don't have a reservoir, it doesn't matter. You can pour liquid in the pulp chamber, and this liquid, by vibration, will go with your tip, your activation tip inside the canal. Irrigation again, and finalize with the 3504, and of course, the final irrigation always with activation as well. So this is pretty much the sequence that we have for applying this system for instrumentation.
Mm-hmm. And all this is available through Medidenta, or how do people order? Is it direct dealers?
Yeah, actually, this is the Genius Pro Flax system is available through Medidenta. So Medidenta is the responsible for selling this system.
Yeah, so it goes direct, and then if anybody has any questions. So Medidenta, just to clarify, has the files. They have the motors that you talked about. Is it the trumpet accessory, is that available already too? Okay.
It is available for and is the trumpet and the scout are exclusive from us, because I designed those tips, and they work very well for finding canals. Another thing that you can do with the trumpet is, you know, when you cut gutta percha and you clean the pulp chamber, and sometimes you see some points here and there, instead of using a burr, just go with your trumpet and you can just remove those little points. Of course, with magnification, you can see better loops, or even microscope. You can see those little parts of sealer that still in the pulp chamber, and you don't want to use a burr to remove it. Just remove with the trumpet. That works very well.
Okay, great. That's great news. So yeah, it's been great going through all this. And I think the last question that we were talking about, you've already talked about it, but so we found the canals, we've shaped them, we've irrigated them. Now what's the last step? We got to fill it with something. So what do you recommend as far as obturation?
So obturation is something that I always talk. I always say the same thing, right? So there's two parts of obturation that bothers us, right? One of the things that I hate is when I try to put a gutta percha cone and doesn't fit, right? So I can tell you that Dr. Nathan Lee, that is a dentist in California, he came with a very interesting approach of manufacturing gutta percha cones. And it's so simple that, again, you can ask why other manufacturers never did that, right? And fortunately now there are more manufacturers doing the same thing, but is thermo-injected gutta percha. So thermo-injection, plastic thermo-injection, is something that is not patentable anymore because it's something so old, right? But thermo-injecting gutta percha, that is a polymer, nonetheless. So it is a polymer nonetheless. So what happens is, instead of hand rolling gutta percha, then you can create a mold that is a perfect design with perfect measurements, and you can inject gutta percha on this mold, and you can definitely rely, if the gutta percha is a 3504, you can rely that it's a 3504. Look, with the development of new files, all these CC files, machine cutted files, you have the metrology of use on these machines, computer-assisted machines, are so high-ended that you can say that a 3504 file in terms of metrology is 3504, right? Mm-hmm. But when it comes to gutta percha cones, the 3504 hand rolled can be a 30, can be a 40. if you go to ISO specifications, they are very nice with the specifications. They say, oh, by ISO, a 3504 can be 35 plus and minus 0.5. So 35 can be a 40 or can be a 30, doesn't matter for ISO, right? Well, matters for us. So you have two options. You can have these calibration rulers, that is very nice. You just put the good pressure cone on the socket, written 35, and you cut the axis if it is the case. Or you can buy thermo-injected good pressure cones. We used to have for Genius in the former company that I used to work, and we are coming with these thermo-injected cones for probably the beginning of next year. But Dentsply, they have the conform fit good pressure. So conform fit, even though it's 2 times more expensive than the normal good pressure, but they are thermo-injected as well. So this is one of the things about obturation that bothers me, or used to bother me a lot. It was the good pressure feeding, right? The second thing that I can tell you about obturation is very simple. I will not even take a lot of time. Every time that you do your preparation and you have a feeding gutta percha, 04, for example, or sometimes even 06, but I like to use 04 because my preparation is always 04. Every time that I have a good feeding of the gutta percha, 04, pretty much the full apical third is one gutta percha cone with little space laterally, right? Mm-hmm. So in all techniques, all obturation techniques, the very end 2 or 3 millimeters in all of them is a single cone technique. And guess what? The apical part is the most important, right? Because it's the one that you don't want to have any space leaving there, any voids, any defects, right? Because it's exactly where you have the communication between what you did as a doctor, as a dentist, as an endodontist, whatever, and your patient. If it is in the middle of your obturation, some voids, that's okay. We don't want it. But that's okay because those will be circumvented by obturation. But in the apical area, you don't want voids because those could be potentially space for bacteria growing and keeping the lesion. So why we accept a single cone technique in the most important part of the canal, and we don't accept single cone technique for the other parts? Makes no sense. Especially now that we have sealers, that bioceramic sealers, for example, that were just one company with the bioceramic sealers here in the United States. That was Bressler with the BC sealer. Now we have other companies like Avalon Biomed, Angelus, Bressler, those companies, and they are giving this option of the bioceramic sealer as well. There are other sealers that are bioceramic that there are 2 pastes that you need to mix, but those are okay as well to be used. So the bottom line is, with the bioceramic sealers, you have a different concept. And this different concept is, now you don't have shrinkage of the sealer. Like the resin-based sealers or even ZOE sealers, they have some shrinkage, right? The bioceramic sealers is the opposite. They have a little 0.1%, but they can, expand very little, but at least they are not shrinking inside the canal. And that's very good. So if the bioceramic sealers, for example, you pour the bioceramic sealer inside the canal, you put one gutta percha cone. And of course, if you want to put more laterally, if you have a lot of space, like canine or even a palatal canal of upper molar that is huge, you can just harpoon some other lateral accessory gutta percha cones, but you don't even need to do any lateral condensation or anything. What I don't like, Mike, and I never, and I know that I create some controversies when I say that, I don't like to plastify sealers. System B, for example, there's plastification of gutta percha, but with the gutta percha, there's a sealer there. And the studies shown that every time that you increase temperature, and look, we increase the temperature for 200 C. And when you increase the temperature for 200 C, the resin-based sealer turns in another chemical. There's studies showing that. So why I want to create this situation inside the canal? Just to compact everything there? The obturation is made by the sealer, is not made by gutta percha. Gutta percha is just a meaning to an end, right? So it means that you use the gutta percha as a core, but you don't use the gutta percha to alter anything. It was not meant to be in this way. What do the sealing of your canal is the sealer. That's why sealer is a sealer. Gutta percha is just to provoke this little pump effect, yes. Be the core. In a case of retreatment, it's easier to remove, and the sealer is never easy to remove. All chemicals that we have in a retreatment is just meant to dissolve gutta percha. Was never meant, and is not meant to dissolve any sealer. There's no sealer, with the exception of ZOE, there's no sealer that dissolves with any of these chemicals. They are just meant to be used with gutta percha. Like orange oil, like all these other, solvents that we have. So pretty much what we want is the sealer sealing the canal, and the flowability of the sealer is very good. The bioceramic sealer, even resin-based. I did in my life tons of single cone techniques with harpooning, some lateral if I have space, with ZOE, with resin-based, and with bioceramics. And I never had any problem concerning the obturation. My problems is, and it still is, and it still is, when I don't clean all the canals, when I leave some bacteria inside the canal, when I leave some space inside the canal. That is the problem. So obturation is something that is not complicated if you have the convenient space and if you have the right material to do that.
No, that's great. Yeah, well, we kind of covered everything in 2 sessions, everything from finding the canals, cleaning them out, irrigating them, obturating them, and even what to do when you perforate one. So great information. And I want to thank you very much for covering it, and covering it also thoroughly. It's been great.
Thanks, Mike. I have to say thank you for you, because this is an amazing experience that we are having together. I hope that we continue with other experiences like personal, hands-on courses, etc. We are planning that, as you know. But thank you, because you come with your perspective, I come with my perspective, and all of a sudden we create a good environment to discuss some very, very interesting points. Actually, as you said, we cover finding canals. It's not easy, right? Even with magnification, sometimes you just don't see what is in front of you, right? We cover Apex Locator. Apex Locator, even though we launched in 1988, when I came back from Japan, we launched what is called 3rd generation of the Apex Locator, that was the APIT Index, Root CX, and all them others that came after Root CX. And it still is something that is debatable. There are some people that want to use the Apex Locator, but they don't know exactly what is the best protocol to be used. We cover instrumentation, we cover heat treatment. That is something new. Actually, is very new. Heat treatment is not even though the first heat treated files came in the 2000s, but nowadays people are talking way more about it. And especially, most importantly of all, for the root canal treatment is the cleaning process, this disinfection with the sequence of sodium hypochlorite, EDTA, and water, activation, all this. So I'm very happy that we cover all the things, but all the other webinars, we are coming back to these issues again in more detail. The next one will be about Apex Locator. So I invite everybody to be in touch again with the next webinar that is about working length determination and Apex Locator. Thank you very much, Dr. Mike.
No, you know, and I think I want to second that. You know, as we go through this, I want anybody who's watching, you know, there's still a lot of techniques. And I think hands-on or some kind of training is always the best way to really pick up on all of this, especially like Carlos, you're saying, you know, the tactile feel can be very different. And, you know, on these webinars, we try to behave because we're not with you. We don't want anything to be taken out of context. But I think if you ever have a chance, I'd welcome you all to take a hands-on course. I think Carlos and I will just have a good time, maybe not behave as much. And I think it'd be a really fun and educational experience for us to all get together with some of our colleagues and spend a day or two and share. So I hope we get some dates soon, and I hope to see everybody attend.
Yep. I hope so as well. Thank you very much, Dr. Mike.
Thank you. You take care.
Yeah.
Everybody.
Bye.
Bye-bye.